over graphing absolute value of f of x and f of the absolute value of x. So if we have functions graphing the absolute value of the function or graphing the absolute value of x inputted into the function, those are things that we're going to talk about. So I will have 4 examples, all of which will already have been graphed to simplify what we're going to do. So I've gone through the process of figuring out how to graph f of x here. F of x looks something like this, and then it goes off to infinity in this direction. It grows pretty slowly going to the right, but it goes off to infinity. This is a hard stop. So at -2, 5, that's the end of the function. So the domain of f is -2 to infinity here. So I've copied f of x down here. The absolute value of f of x is essentially reflecting all negative y values over the x-axis. So if we look at this function, -2, 5 is still on the function. -1, 0 is still on the function. And then what happens is, as we continue to move forward, all of these negative y values get reflected over the x-axis and become positive y values. That's what happens when you take the absolute value of any sort of thing. So any function value, which is a y value that's negative, becomes positive. So 2, 3 will be on the graph. So this becomes positive. 7, 4 will be on the graph. 14, 3 will be on the graph. So it ends up coming back down, so to speak, after that. So there's this, and then there's this, and it starts to go. Now, what would end up happening if this graph continued is this graph ends up crossing the axis again. What will happen in absolute value of f of x is eventually, and it's pretty far down there, once it hits the axis, it then bounces back up, and it's still pretty slow, but it would never cross the x-axis. It would always be positive. So that's what would happen in the long run in this function. Now, f of the absolute value of x, what ends up happening is that all negative x values that are substituted in, we have to take the y value that is associated with the positive x value. So everything on this side kind of stays the same. So 2, -3 stays the same. 7, -4 stays the same. 14, -3 stays the same. So we have a graph that over on the right side of the graph looks identical. Now what happens is, as I start to substitute in negative x values, the y values that are associated with the positive x value that's kind of with that are what we see. So if I sub in -2 for x, I'm going to end up getting the same y value that I would get if I subbed in +2 for x. So I'm going to end up getting -3 as my y value if I sub in -2. So what's going to end up happening is I end up reflecting all negative, or I'm going to reflect all positive, that's probably a better way of putting it, all positive x values over to their negative counterparts. That's probably the best way of putting it. So notice it basically just reflects over this line. So this point gets reflected over to here. However, I have to really be careful, and I cannot add to the domain. And this is a risk when we're doing f of the absolute value of x. because it's tempting to just continue and mirror everything over. However, notice that the original domain of f of x stops at -2. I cannot add to the domain, so I have to have a hard stop at -2. So when I had -1, I would have to find the exact y value that's associated with -1, and that mirrors over. But I can't continue that with finding -3's mirror. So -3 has some sort of y value that's associated with it. I can't continue to do that because if I substitute in f of the absolute value of -2, that's going to give me f of 2. But if I substitute f of the absolute value of -3, that's a problem because -3 was never in the domain in the first place, so I can't even do that. So I can't continue to add to the domain. I have to have that stop here. 3 more examples. I'll go quicker on these. So here's f of x equals -1 over the absolute value of x, or I'm sorry, the square root of x plus 4 plus 3. So I kind of go through the process of getting over to here. Then here's f of x. Absolute value of f of x, by the way, the domain of this problem, I probably should have written that. The domain of f of x is -4 to infinity, where -4 is not inclusive because we have the asymptote. So if I graph absolute value of f of x, once again, that is reflecting negative y values up to become positive y values over the x-axis. So what's going to end up happening is all of these values down here are going to reflect up and become positive. So I have this asymptote at 3, y equals 3, and I have this asymptote at x equals -4. So nothing really changes about the graph until I get to this value where it intersects the axis. So once I get to this value where it intersects the axis, it then shoots up like this. And so it's a little curvy, but it kind of shoots up like this because everything that was down here gets reflected up. So notice that this is going to cross our supposed horizontal asymptote because the absolute value kind of eliminates that asymptote as we're going toward -4. But we still have the vertical asymptote here at x equals -4. Now f of the absolute value of x, this means we reflect positive x values over to their negative counterparts. So I have this graph kind of looks very much the same as I'm in positive x world. So I have this horizontal asymptote here. And then once I hit here, it kind of bounces back like this and mirrors everything. So whatever x equals 1 was, that's going to be the same y value as -1. -3, same y value as -3. But notice this one goes on to infinity. This one has to stop at -4 because -4 is not included in the domain. So because -4 is not included in the domain, I cannot continue to mirror everything. So basically I reflect or I mirror all the positive x values over to their negative counterparts, but I cannot add to the domain. All right, 2 more examples. This one, I've already graphed f of x. So if I'm graphing the absolute value of f of x, that means that everything down here is going to reflect up. So this is at like 0.4 or something. And this is at, I think it's like -7 or -8, something like that. But we used to have -2, -4, and -6, -4 over here. Well, those are going to get reflected up, so I'm going to be at -2, +4, and -6, +4. So my graph will, instead of looking like this, it will look something like this. And I put this intersection at a bad spot, so it should be somewhere over here. And of course, that's what happens when you're trying to draw on a tablet. So notice that everything gets mirrored up, but I can't just continue going because I had this gap in my domain and also in my range here. So this is kind of what absolute value of f of x looks like. Now, f of the absolute value of x, what's going to happen is notice that I had this going on all the way over here. I have to continue going until I reach x equals 0. And then everything kind of mirrors over. So whatever x equals 1 was, that's going to be the same at x equals -1. Then I get to x equals -2. Now x equals -2 is going to mirror exactly what was at x equals +2. But then I don't have anything between -6 and -2 in my domain. So I'm going to have a pause. I'm going to have a stop. And then I'm going to start again once I get to -6. And -6 will match exactly what was at x equals +6. So it's going to look something like this. So what ends up happening is everything continues to match. So at -10, it's going to match whatever it was at +10. So it's going to look mirrored over on the left side. So everything that's on the right side is mirrored over on the left side, except we have this gap in the domain that I have to continue to represent when I have f of the absolute value of x. Finally, let's have this piecewise function that has a line, then a horizontal line, then some sort of parabolic thing. Absolute value of f of x. This continues to look like this, and then everything that was below the axis gets reflected up. So it will look something like this. Then I have a horizontal line here, and then I have this parabola. So at 6, 5, that continues to be on the graph. So this graph kind of, let's pretend like this is still down here, and I graph my parabola. That's kind of what this would look like, but then everything up here gets reflected over like this. So this parabola, this last part of the parabola kind of is going to end up looking something like this. So everything that was below gets reflected above. Now, when I look at f of the absolute value of x, everything that is on the right side of the graph stays exactly the same. So 6, 5 continues to be an open circle. So it looks something like that. Now this line essentially goes away, and I need to reflect everything over to this side that was on the right. So I'm going to reflect it over to be on the left. And so this parabola kind of continues, and I end up at -6, 5. Except notice that my domain stopped at -4. So that means that instead of going all the way to -6, I actually have to stop what I'm doing once I get to -4. So once I get to -4, that's actually only a little bit up here. I then have to put an open circle because this -4 was not in my domain. So it looks something like this. And everything mirrors over, except I have to stop when my domain restrictions officially stop. So remember, in f of absolute value of x problems, there is no adding to the domain. And if we have to summarize it one more time, f, or absolute value of f of x problems, we reflect any negative y values up to be positive. And f of absolute value of x problems, we reflect all positive x values over to y values as long as we don't add to the domain.